All right, we're going to finish up our notes on 4D. So we're still looking at our trigonometric functions and our trigonometric identities. And so we are starting here. So sometimes you will only need to find one trig function for a given angle. And so if we have an angle that is too big or too small, then we first need to find the coterminal angle. Because our coterminal angle will be somewhere on the unit circle, and then it'll be a lot easier for us. And we are familiar with doing this for coterminal angles. Since we look ahead, these are all in radians, we want to either add 2 pi or subtract 2 pi. So if it's too big, we would subtract. If it's too small, we would add. So looking at example 4, I'm going to go through 3 of them. So for the first one, it just asks me for cosine of 2 pi over 3. So I want to use my unit circle, and I need to find this angle on my unit circle. So 2 pi over 3 is right here. Because it is cosine of it, I need the x value of my terminal point. So negative 1/2 is my answer for cosine of 2 pi over 3. So then looking at the one to the right, I need to find tangent of negative pi over 3. So this is too small, so I'm going to make a note here, which means I need to add 2 pi onto it until I get an angle that is on my unit circle. So I'm going to do that underneath here. So I have negative pi over 3, and I'm going to add 2 pi. Right now, I don't have common denominators, so I need to create common denominators. So I'm going to multiply 2 pi by 3 over 3. When I do that, I have negative pi over 3 plus, this will turn into 6 pi over 3. And I can always double check, 6 divided by 3 gives me 2, so those are equivalent to each other. So now I can add them. So negative pi plus 6 pi is 5 pi, and then when we add fractions, we do not change our denominator. So instead of finding tangent of negative pi over 3, I actually want to find tangent of 5 pi over 3. And 5 pi over 3 is on my unit circle, so I'm going to bring that back in. So 5 pi over 3 is actually in quadrant 4. So we're looking right here. Now on this unit circle, I have my tangent. My tangent is the numbers on the outside of our terminal points, so it is negative square root of 3. If we don't have it on our unit circle, to find tangent, we're going to do sine divided by cosine. So we're going to do our y value divided by our x value. So I'm going to do that. I'm going to slide this over. So I need to do negative square root of 3 over 2 divided by 1/2. Well, if I'm dividing by a fraction, that is the same thing as multiplying by the reciprocal. So I am going to take the fraction in my denominator, and I'm going to flip it and multiply it to my numerator. So when I do that, it's no longer in my denominator here, it's gone, and I need to multiply straight across. When I do this, I do recognize that I have a 2 in the numerator here and in the denominator, so those 2's would cancel. So I'm going to keep covering this up. So my 2's cancel. So I would have negative square root of 3 over 1. Well, anything over 1 is itself, so that is how I get the negative square root of 3. Which, if we look back at our unit circle, for 5 pi over 3, that was our tangent, which is what we got. So the last one that I'm going to go through is sine of 19 pi over 4, and then I'll leave this one for you to do. So sine of 19 pi over 4, well, 19 pi over 4, I know is too big, but if you're ever not sure, go ahead and take a look at your unit circle, see if you can find it, and then if you can't, that means you have to find a coterminal angle. So down here, I am going to subtract 2 pi. I'm going to scoot this a little bit so we can see what I'm doing. And again, I need to make common denominators. So I'm going to multiply 2 pi by 4 over 4 since I want the denominator of 4. So underneath, when I multiply this, technically my 2 pi is over 1. So 2 pi times 4 gives me 8 pi. 1 times 4 is 4. So I can subtract these now. Well, 19 pi minus 8 pi would be 11 pi. My denominator stays the same. 11 pi over 4 is actually still too big, so I'm going to subtract again. So I'm going to bring that down here. Since I already made common denominators, I know I'm subtracting 8 pi over 4 from it. So 11 pi minus 8 pi is 3 pi, and then I have the same denominator. This angle is on my unit circle. So sine of 19 pi over 4 can be rewritten as sine of 3 pi over 4. And then I can find that using my unit circle. Sine is going to be the y value of my terminal point. So grabbing my unit circle, 3 pi over 4 is right here. So the y value of my point is square root of 2 over 2. And we're done. So we're going to flip to the next page. On this page, we're going to be looking at different reciprocal identities and Pythagorean identities for some problems that are a little bit more complicated. We're still looking at terminal points and sine, cosine, and tangent, but I could give you a different piece of information and still ask you to find those trig functions. So at the top, this is pronounced cosecant, and we can write this as 1 over sine of t. Those are equivalent. Secant of t is 1 over cosine of t, or the reciprocal of cosine of t. Cotangent of t is 1 over tangent of t. But we also can write it differently, so that's why it's on here twice. For tangent of t, that is sine of t divided by cosine of t. So cotangent of t, we said was 1 over tan. I could also do the reciprocal of tangent. So instead of sine over cosine, I would have cosine of t over sine of t for cotangent. For my Pythagorean identities, I have 3 equations that I can use. So the first one I have is sine squared plus cosine squared equals 1. And I want to point out that the exponent is after sine but before the variable, because if we put it after the variable, it would look like just the t is being squared, not the entire thing. So we want to have sine of t, whatever that is, and it would be squared. So this is like the equivalent of, let me write it in a different color, sine of t inside parentheses squared. So some mathematician thought this looked too complicated or too like muddy, and so this is how we write it, but they are the same thing. Our second Pythagorean identity would be tangent squared plus 1 equals secant squared. So again here, we put it after the tan but before our variable, but the entire thing is technically being squared. And then the third one we have is 1 plus cotangent squared equals cosecant squared. And for all of these, when we're using t, that would be our angle. So whatever angle on our unit circle we're using. So we're going to look at example 5. So let me scoot this up. I also want to mention you'll be given these on the test. You'll have a formula sheet for those. You do have to know which ones to use and when, but you do not have to memorize them. So for example 5, it says if cosine of t is equal to 3/5 and t is in quadrant 4, find the values of all of the trig functions at t. So to start off, if I need to find all 6, I'm actually going to label them on the side so I can hopefully stay a little bit organized. So sine of t, cosine of t is already given to us, so I'm not going to include that over here. Tangent of t, we would have cosecant of t, which is the inverse of sine. Secant of t, which is the inverse of cosine, and then cotangent of t. So this is where I'm going to put all my answers at the end, and I hope I have enough room. So I'm given cosine of t, and so I want to use one of these equations to find another piece of information that I can use. So cosine, I want to use the equation that contains cosine, and that's the first one. So I'm going to use sine squared plus cosine squared equals 1. So I can go ahead and plug in my fraction in place of cosine of t, and then I do have to square my fraction since cosine of t is being squared here. So I have sine squared plus, I'm going to put my fraction inside parentheses and square it, and then that equals 1. So when I simplify this, I need to square both the numerator and the denominator. So I have sine squared of t plus 9 over 25 equals 1. I want to solve for sine of t since that's one of the trig functions that I need to find. So I'm going to go ahead and subtract my fraction from both sides. I'm not going to show that step because I'm running out of room. But what I have left is sine squared equals 16 over 25. I do not want sine squared, I just want sine of t, so I have to take the square root of both sides. When I do that, I take the square root of this, I take the square root of the numerator and of the denominator. I don't want to forget the denominator. And so I have sine of t equals, and whenever I take the square root, it would be plus or minus. I'm not going to write it yet. The square root of 16 is 4, and then the square root of 25 is 5. So I'm going to go back up here. If my angle is in quadrant 4, so quadrant 4 is this one here, I know any point in that quadrant has an x value that's positive and then a y value that's negative. So I know that sine of any angle is always the y value of my terminal point, and so this has to be negative since I'm in quadrant 4. So over here, I'm going to put negative 4/5 for sine of t, and then I have 4 left to find. So I want to start with what's the easiest. If I have cosine of t, looking back at the top, oh my goodness, I am so sorry. That was loud, if you heard it. So if I have cosine of t, that will help me find secant. So all I need to do to find secant is take this fraction and flip it. I need to do the reciprocal. So I'm going to make a note to myself, secant of t equals the reciprocal of cosine of t. So the reciprocal of 3/5 would be 5 over 3. So over here I have 5 over 3. That is a perfectly fine fraction. I don't need to rationalize anything. I can leave it like that. If I have sine of t, that will help me find cosecant. To find cosecant, I want to do the reciprocal of sine. So I'm going to make a note. Cosecant of t equals the reciprocal of sine of t. So if sine of t is negative 4/5, that means cosecant of t would be negative 5/4. I just flip the 4 and the 5. If sine is negative, then cosecant has to be negative. So the last two I need are tangent and cotangent. If I can find tangent, then I know I can just flip it to get cotangent. I also know that tangent of t is sine divided by cosine, so that's going to be what I do to figure out tangent. So tangent of t equals sine of t goes in the numerator, which is the negative 4/5, and I'm dividing that by cosine of t, which we were given, which is the 3/5. And then I know if I divide by a fraction, that is the same as multiplying by the reciprocal. So I'm going to take this, pull it out of my denominator, and I'm going to multiply by the reciprocal, which is 5/3. When I do that, it's no longer down here, so I'm going to cover it up. And I can multiply straight across. I do recognize that the 5s will cancel. I have one in the numerator, one in the denominator, so I'm going to cross those out. So what I have left is negative 4/3. So tangent of t is negative 4/3, which means cotangent of t is just the reciprocal of this. So I'm going to flip my fraction, and I would have negative 3/4. And we found all of our trig functions. We have the 5 here, and then the 6th one is what we started with. So even though we were only given a small piece of information, using these identities, we can find all 6. I am actually going to leave example 6 for you to try. You can check the answer key to see if you got it right. This time you are given sine to start, but my hint to you is we still want to start with sine squared plus cosine squared equals 1. And that will let us solve for cosine. And then you can find the remaining ones left. This one is in quadrant 2. Quadrant 2 is this one. Any x value would be negative and any y value would be positive. So you need that when you are finding your other trig identities. So at the bottom it says if you are given ... If you are given sine of t, you want to use sine squared plus cosine squared equals 1. Because if I know sine, I can plug that in here. I can find cosine. Same thing for cosine. If I am given cosecant, I just want to flip it to find sine of t. So I'm doing the reciprocal. If I'm given secant, I want to flip that to find cosine of t. If I'm given tangent, I want to use tangent squared plus 1 equals secant squared. That's the only trig identity that has tangent in it. And then if I'm given cotangent, I want to use this trig identity. It's the only one with cotangent in it. So I am going to go through example 7, which is on the back. So I'm going to go ahead and flip this over. So this time I'm starting with cotangent. It says if cotangent of t is equal to 2/3 and the terminal point of t is in quadrant 1, find the values of all the trigonometric functions at t. So I'm going to make a couple notes here. Quadrant 1 is here. My x value has to be positive. My y value has to be positive. So sine and cosine will both end up being positive. And then I'm given cotangent to start. I'm going to actually start off a little bit, I don't want to say easier, but if I'm given cotangent, I know if I do the reciprocal of this fraction, it will give me tangent. So without any work, I know tangent of t is 3/2. All I did is I flipped my 2/3 and I got tangent. So we got 1 down, we have 4 more to go. So going back to the trig identities and the Pythagorean identities, if I'm given cotangent, I want to use one of these 3. So the one that has cotangent in it is this third one, so this is the one that I'm going to use. So 1 plus cotangent squared equals cosecant squared. So I want to plug in what I know. I know cotangent of t is 2/3. So I have 1 plus 2/3 inside parentheses, and that is all being raised to a power of 2, is equal to cosecant squared. So I'm going to go ahead and solve this. When I square my fraction, I square both the top and the bottom. So that would become 4/9. And then when I add those together, I get 13/9. And I'm just going to double check that in my calculator. And we do want it to be in a fraction because that's going to help us when we take the square root. So if you get a decimal in your calculator, do math, enter, enter, you get a fraction. So I want to take the square root of both sides, so the square root of the entire fraction, so the numerator and the denominator, and then the square root of cosecant. So the square root of 13 is going to be the square root of 13 because that will be a decimal. And then the square root of 9 is 3, and that will be equal to cosecant of t. So since I'm in quadrant 1, I know it has to be positive because cosecant is the inverse of sine. So I have cosecant, which means if it's the inverse of sine, I can go ahead and flip this fraction and do the reciprocal to find sine of t. So I'm going to do that up over here. So sine of t is equal to 3 over the square root of 13. However, I have to rationalize this denominator. I cannot leave it with a radical in the denominator, so I'm going to multiply the numerator and the denominator by the square root of 13. When I do that in my numerator, since this is not inside a radical, but this one is, I just squish them together. So I have 3 square root of 13. When I multiply square root of 13 times the square root of 13, I would technically get the square root of 169, which ends up being 13. So the square root is gone for my denominator. And then this is my final answer for sine of t, since my radical is now not in the denominator. So what we have left is cosine and secant. So I have some options. Since I have sine of t, I'm actually going to use my Pythagorean identity of sine squared plus cosine squared equals 1. So I am going to plug in what I know. That's being squared. All right, so when I do this, I need to square everything. So my 3 is being squared, the square root of 13 is being squared, and the 13 is being squared. So 3 squared is 9. So I have 9 times the square root of 13 squared. Well, the square and the square root cancel, so that's 9 times 13 all over 13 squared, which is 169. I literally just said it. And then I can bring down everything else. So this looks really messy. So we want to simplify it. I have 9 times 13 divided by 169. So I'm going to do that in my calculator. So I'm going to do 9 times 13. Whoops. And then I hit enter. And then I'm going to divide by, sorry about that, my denominator, so 169. And I get a decimal. So I'm going to do math, enter, enter, and I get my fraction of 9 over 13. So I'm going to rewrite this again as 9 over 13 plus cosine squared equals 1. And then I want to solve for cosine. So I am going to subtract this fraction from both sides, so it'll cancel out over here. And I'm left with cosine squared equals, when I subtract 9/13 from 1, I'm left with 4/13. I don't want cosine squared, I just want cosine. So I have to take the square root of everything. So I have cosine of t equals square root of 4 is 2. Square root of 13, I'm going to leave as the square root of 13. And then again, I can't leave it like this, so I have to rationalize my denominator. I'm going to multiply both the top and the bottom by the square root of 13. And I would get 2 square root of 13 over 13. So I have cosine, and if I have cosine, that means I can do the reciprocal to get secant. When I do secant, you can do this reciprocal and then rationalize the denominator. If I just go back one step though, I have 2 over the square root of 13. Do the reciprocal of this one, and then your square root isn't in the denominator anymore. That would be the easiest, but I do want to show what it looks like if you do this. So I have 13 over 2 square root of 13. And I'm going to multiply this. So I have 13 square root of 13 over 2 times 13, because it's 2 times the square root of 13 times the square root of 13. If I multiply those two, I get the 13, and the 2 is still there. From here, I can cancel out the 13s that are not inside the square root, and that's how I get the square root of 13 over 2. And we were able to find all 6. So we were given cotangent to start, we found tangent, we found cosecant, sine, cosine, and secant.